So once more, welcome everyone to the lecture for today. It should be mastering Rust, enums, pattern matching, control flow, and iterators. So here are some things I actually used yesterday from our implementation of that library application that I had not taught before. An example is the pattern matching, although I've spoken about it before and I have probably used it before, but I had not gone deep as to, talk more about it. Then control flow, I have spoken about control flow, but not in-depthly. Then another interesting thing I used was iterators. I used different iterators yesterday. Like I used dot position, I used dot find. I had in truth not actually, taught this in previous class. And that's exactly why I was like, this class would be a class where I would go deep into that. It will be more of the slide class, as I would just be explaining what all of these are, and then it would not be the practical one. So moving on to the slide. Okay, sorry. Did I display the wrong class? Okay, yes. So enums. What are enums? Enums are literally a way to define types by enumerating possible values. What does this mean? This means that there are certain types that you might want to come up with, or a collection you might want to come up with, but they don't have a specific type. Enum might be your go-to. And so, for example, you might want to have a collection of probably talk of the traffic lights. And then you want to have the first field to be red, the second field to be yellow, and the last one to be green. When you talk of traffic lights, those three comes to your mind. So you might want to have an enum that actually identify these. It might not be easy to, use struct for this, as its struct might probably work for it, but it might not be the right implementation to use. So in that kind of case, enums is probably what you would want to use. So possible values, it's probably what you want to use enums for. And that's exactly what the example we have on the slide shows. This basically the syntax enum, and then the name of the enum. For this case, it's direction. And so what are the fields in the enum? It has up, it has down, it has left, it has right. So enums basically allow you to define a type by listing its possible variants. And this actually makes your code more readable and robust. And what does this mean? This means that you can basically build up different types using enums. You can have an enum that's embedded with different types, and these different types are embedded with structs, and the struct is embedded with another enum, embedded in another struct, in another vector. It can go so complicated like this, and all of this kind of creating of complicated data structure is actually possible by having the enum. Enum is one powerful tool you can use to do something like this. It allows you to create a robust variant of possible values. And that's exactly what enums are. Attaching data to variant. Enums can basically store data with their variants. What does this mean? This is exactly, sorry. This is exactly what I've just explained earlier. An enum can basically allow you to store data in it. So you can have different types, different data types in the different variants of the enums. So the example we have on the screen here shows message. For this, message has quit, it has move, it has write, it has change color. Now, all of these are different variants on the enum. But these different variants have different data that is being stored in them. Quit is just a variant with no data that is stored in it. But notice move. Move actually looks like it's a struct that is storing X and Y value. Write is looking like it is storing a string inside it. Change color is basically storing like a tuple inside it, a tuple of I32s, three I32s. So basically, each variant can hold different types and any amount of data. And this actually makes sense because it allows you to have a robust uh, use of data. And that's exactly what we see from this. Your ability, imagine this struct move is not having X as I32, rather it's having another struct inside it, and that struct is having another enum inside it. So see, that becomes so robust. And that's exactly one of the usefulness of enums. Enums, you don't just use them as variants. You don't just have variants in them. Sometimes you literally have data you can store in them. Enums in action. So practical use case of enums. And it's true from previous classes, I have probably not used enum, but I think when Ogaski asked a question in one of the previous classes, I explained how enum can be used in that case. And in fact, I think Cox, they also made mention about what about enum, would we be using enum at all? I said we would be having a class on it, and here it is. So this is the practical use of an enum. So most times enum are used in state machines, error handling, and complex data structures. So most errors you would have, even when you write your smart contract, most smart contracts talk of Concordium, you talk of Ink, you talk of our very own Soroban smart contract. Most of these error handlings are done using an enum. An enum just basically have your set of errors. And so that easily makes sense because remember, from what we have said earlier, we said an enum have different types of possible values. So your errors can have different possible returns. You could have an error that says data not found, have an error that says string length not enough. You know, have different types of error, have error that the server has crashed. You can have all of these error types, all of these error variants inside your enum. And that's, in fact, one good thing you use enum for error handling. And in fact, you can even pass in different data and store it inside that enum where it's even displays not just the error, but string, properly use string from the error that is coming into it. And that's one use case. So from what you can see on the screen, basically, it's a function that actually implements this particular enum that was declared earlier, the message enum that has move, quit, write, and change color. How then is it used? This is a function process message, and this function process message basically does four different things, and it uses the match keywords to match whatever the input is. So in this case, it takes in MSG, which is the message. And so whenever the parameter of MSG, which is the message that one of these comes in, it matches it. Here it is. It matches it to whichever it is, and it performs an action. So it's basically used to perform different actions based on the different variants of the enum. So for this case, if it sees a message with the enum quit, it basically prints to the console quitting. If it sees a enum with the message move, it basically takes in the data it has stored, and it can basically use the data it has stored to, in fact, print something on the console. It doesn't necessarily have to be that it is printing. It can perform different actions based on what you want your program to do. This is just an example of how you can use an enum that even have complex data structures, an enum that have not just the variant, but even data types that are being stored in the variant. So for write, in this case, it has like a string attached to it, and that string is text. So it destructures it, takes in the string, and then it prints it out. And here it is writing text, and it basically writes that out. Then the next one is change color, RGB. It basically destructures it here, and then it prints it out. So that's just basically how you use the enum. And most time, enum is usually used with the match pattern because it's easy to basically match all of the variants of the enum. Now, one of the things, just like I've made mention of, match is one thing we'll be discussing in this class in-depthly, but just talking about it, for a match, you cannot have a match without handling all of the use cases in that match. What I've just made mention of, I know it could be confusing a little bit, and that's fine. You'll get to understand more as we proceed. And with respect to what I've just said, it means that, for example, this message enum, it has 4 different cases it can ever be. It is either it is quitting, it is either it is moving, it is either it is writing, or it is changing color based on, based on these 4 variants that it's here. And so the matching basically matches this based on the inputs and the 4 scenarios that could ever happen here. So it's a very good one that enums and the match pattern goes hand in hand, because the match pattern basically takes in things that have a complete variant. So up to this point, does anyone have any question, or do I proceed like that? Are we fine? Can I get a thumbs up if you are fine? Okay, okay. Okay, John, you have a question?
Okay, yeah. So I joined like a bit late, so I'm just a bit confused, if I might say. But I think I'll just like ask you my questions later. So let me just
No,
try and
no.
go.
Do well to ask your question now, so it's easier for you to comprehend as we move on. You know, if you do not have the basic understanding from the basics that we are currently looking at, it might be quite difficult to, to catch up at the future while we have progressed more in the course. So do well to ask your question now, so I can settle that, so you don't get much confused.
Okay. I've still not been able to articulate my questions properly. Once I have it together, then I'll ask you, because I'm doing some research here also.
Okay.
Trying to follow up. So once I have like a structured question, I'll be able to ask you. But
Okay, great.
like I just joined late. That's my real issue right now.
Okay, no problem. Do well to always try to join early, as it's easier to, flow with the teaching when you start right from the beginning. So
Yeah. Yeah. Thank you.
you're welcome. So I would continue the class. So moving on, introduction to pattern matching. Yeah, that's basically what I made mention of, that we would talk about next in today's class. Pattern matching is a powerful feature in Rust that allows you to compare a value against a series of patterns and execute code based on which pattern matches. That makes sense. In fact, it's just like the name, match. So it's basically, what it does is it matches a particular value with respect to different series of values. And if we go back to the example we had here, where we used match, you notice that we match this MSG, which is the parameter. It's a data type message, which is this, an enum. We matched it with all the possible variants of the enum. So it matches the first variant, the second variant, the third variant, and the fourth variant. So all it does is it matches all of the variants, and whichever one matches based on the parameter or the input given, it executes the code based on it. So in this case, if the parameter here matches with quit, it basically does what? It runs this line of code, print line quitting. Basically runs that line of code. So obviously, you could have a different implementation here other than printing quitting, obviously. But the idea is it basically matches the corresponding value that it's being matched against with the series of values it has. And I made mention that it's a very good one because it compares all of the variants. Now, struct is literally, enum is literally not the only thing the match pattern compares. Obviously, it compares other things. And this is the example of what I'm talking about. Basic syntax of the match pattern. The match, then the whatever you want to match, the value, the first pattern, the second pattern, and then notice something here, like an underscore here. Why do we have an underscore here? This is because to explain the match pattern, we can basically compare the match pattern with an if-else statement. But in this case, the if-else statement, in this case, we could have an if-else statement that doesn't contain all of the scenarios, all of the possible outcomes. But one thing the match pattern does is it contains all of the possible outcomes. So it matches it with the first pattern, and if it doesn't, what if the value you are comparing the first pattern with is not there? The value you are comparing with the second pattern is not there. What exactly then should happen? That is exactly why we said the match pattern basically covers all scenarios. In this case, the underscore is used as whenever all the other series of variants are not that the value you match to these patterns are not matched, basically run this default. And so in that case, it covers all the scenarios. So if all of the other variants you are trying to match up is not available with the value, okay, I had something. Okay. Is not available with the value, then you basically run this default code. And that's exactly what it means. Now, if you go back to this code, why exactly am I trying to explain this and emphasize it? This is because matching is actually one of the strongest things you would ever see in the Rust programming language. It's one of the strongest features, one of the most powerful features you see. And it basically allows you to cover all of your scenarios. So if you go back to this particular case, we did not have that underscore. I believe the question should have popped up that why did we not have this underscore that we have here? This is because this particular message, this particular data type covers all the scenario, and I've explained that earlier. Is just to bring our mind back to it. All the scenario that can ever happen for this particular data type is either it quits, it's either it's move, it's either it's right, or it changes color. Because what you are passing in as what you are matching it with is basically an enum, and all of these are the scenarios in the enum. And so that's exactly one reason why I said pattern matching is one of the best things you can use on enum. So pattern matching is exhaustive, meaning you must handle every possible case, which prevents errors and make your code safer. And this is one of the reasons why I made mention that pattern matching is quite a powerful feature in Rust. This is because with pattern matching, you literally handle every possible case you can have. Pattern matching with enums, I guess we have already handled this in the previous example, but in this example, it's just, repetition is just what makes knowledge stick the more. And that's exactly why I did this, adding more examples to it. So in this example, we have an enum coin, and the coin have 4 different variants. So for all of these variants, you can basically create like a function that matches all of the variants. And that is exactly how the match was used here. So for the coin, whatever coin you pass in, if the coin type is a penny, it returns 1. If the coin type is a nickel, it returns 5. If it's a dime, it returns 10. If it's a quarter, it returns 25. And that makes sense, basically. So what you are returning is this value. And this value you are returning is here. It's a U8 value. And so pattern matching with enums allows you to easily access the data stored in the enum variants and handle each variant appropriately. So nested patterns and matching with guides. So in this case, we have a nested pattern with matching guide. What does this mean? Notice that this enum basically have 2 variants, and these variants literally have data that they can store. Like for example, this car has the make and the year. For bike, it has the type, which is a string. So if you pass in the first variant of the car, you need to pass in the make and the year. Now, how can we match two of these 2 different variants of this enum together? So this function describe vehicle literally takes in the enum, and what it does is it matches it. So it matches the enum. It says if the vehicle is a car, then it runs this line of code. So now, what exactly is this thing now saying? This thing is saying that you can have a nested pattern. And this is the example we can see from the screen. This particular car, which is the vehicle, is nested because it even have another conditional statement inside it. It says if year is greater than 2020, print a new, then it takes in the year that it has been the make, I mean, and then car from whatever year it is. Now, if not, it should print an older car and it should just return the make. This is literally nesting a pattern, because what you are doing is you are matching a vehicle car with a vehicle bike. And in the same matching of the vehicle car, you are also comparing. You are trying to check if the year of the model of the car is an older car from 2020 to a newer model. And that is exactly a very beautiful example of the matching guide. And you can do this with matching with the match pattern. Imagine if you have a much more robust implementation. You can easily do all of this implementation with the match pattern. And that's what makes this very strong and powerful. So does anyone have any question up to this point, or can I proceed? Just want to ensure that everyone is following me up to this point so I can proceed. Can I get the thumbs up? If there are no questions, then I would proceed. Just to ensure that everyone is following up with me. Can everyone hear me? Hello? Okay, I guess I can be heard then. I got the thumbs up. Okay, thank you, Levi. So I would continue. The pattern match versus the iflet. Yes, excellent. The iflet is something I used from yesterday's class. If we all can remember, I think I should show where I actually used the iflet from yesterday's class. Okay, let me share my screen and show how I used the iflet. So I'll share my screen in a bigger pattern. I'll share my entire screen so I can show how I used the iflet from yesterday and how powerful it can be. So basically, here is the if-let I used yesterday. I was trying to destructure what the results from this iteration, the iter value coming from the position. What this position returns is actually an option enum of a U size. So it returns an option enum of a U size. So I'm trying to perform a comparison with the results. And so one beautiful way of destructuring an option enum is using an if-let statement. So an if-let statement, you destructure it, and at that, while destructuring it, you basically compare it with something else. And in our case, since it's an option enum, if it is not that value, then it is none. So in that case, if it is not the value, that's the position, because this returns an option of view size. If the position is not there, then it's definitely going to be a none, and that's exactly how we were able to use it from yesterday's class. But then, what's the difference between the if-let statement and the match statement? So I'll start sharing the slide again, and then we talk about that. The difference between the if-let statement and the match. So when to use each? For the pattern matching, it's best for handling multiple cases or complex conditions. But for if-let, it's ideal for simplifying control flow when you are only interested in one case. And in that particular situation, whereby you are destructuring an option enum, in that particular case, it can be one of two things. It is either the value or none. So in that case, the if-let is literally ideal, and you can use it as a control flow when you are interested in just one value, and that value is the value you get from the option enum. And if you do not get the value, the only other value you can get from that case is the none. But then, going back to the match pattern we explained earlier, you can basically use the match pattern for so many cases, that's multiple cases, whereby you are matching just one value to different variants. And in that case, the pattern matching is literally the best thing to use. So if-let provides a concise way to handle a single match arm, making your code cleaner and easier to read. And that's exactly why I used it from the class when we were creating the library, and we can see. Introduction to if-let. Purpose. If-let is a syntax sugar that simplifies matching against a single pattern, especially useful with option and results types. And that's exactly what I've made mention of. That because for option, it is either the value or none. And for results, it is either the value or an error. So those two things make sense because it cannot be more than two things you are trying to match. And in this case, when you are matching the option enum, you are trying to destructure it simultaneously, because if you go back to this, what an option enum returns to you is a sum value. So the sum value in this case is how you are destructuring it and using the value inside the sum value. So the construct helps in case where you don't need the full power of a match statement, making your code more sustained. So you don't always need to use a match statement, because a match statement is powerful, and sometimes you don't need to use the most powerful things in your code just to make your code readable and faster. Using if-let for control flow. Example is handling optional values, and that's what I've said. It's mostly, in fact, used for optional value, where you have the sum as the result of the option, or you have a non-value. So for this example, a config max is the variable and it stores some 3U8. So it stores a 3 value, which is a uint8 value. And so just to match it, you can match if let's the sum that this sum max is literally the structuring this config max. So this config max we can see here is the structured, and whatever is inside the sum is what this max is. And then it literally prints the in this case we are printing it. You can obviously do whatever you want to use the value max, whatever you want to use it for, you can basically use it for. But in this case, we are printing it. And printing to the console, we are saying the maximum is configured to be the max. And that's exactly what we did, using the if-let to print the value from the option enum in this case, which is the sum 3. So the if-let is perfect for situations whereby you want to execute code only if a certain value exists, such as when dealing with option enums. Handling both matched and unmatched cases. Now, this is an example to show a situation whereby we are trying to handle both the matched and the unmatched cases. So the example we see on the screen is literally a variable that is named stack. And what the variable does is it creates a new vector. And so inside the new vector, it pushes 1 in, pushes 2 in. So basically we identify that the data it's trying to push is the I32 value, or in this case, it's an integer anyways. So it pushes it 1, 2, and 3 in, and then it tries to use the while-let. So the while-let is basically used to go through a series of values, especially inside arrays, vectors. And in this case, in this example, we are trying to go through the vector. Obviously, when you talk of while, you are trying to think of a loop in your mind, and that's exactly what it does in this case. So it says while let some top is equal to stack.pop, then print top is whatever the pop is. Can you see? And this example is a perfect example to use the while let. So instead of using the if let with else, you can combine it together and use the while let. So the while let basically loops through all the cases, all the scenarios you want, and then whenever the particular scenario you are interested in pops in, it basically calls that function, or it basically executes whatever it's in that particular line of code. So by combining the if-let with else, you can handle both the case when the pattern matches and when it does. And this basically makes your control flow more robust. So before moving to an interesting one, which we also discussed yesterday, I'll come back to also check if there are still any questions coming up. Are there any questions, or I can get a thumbs up to move on? Are there any questions? Or do I get a thumbs up to move on? Okay, 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 that works with me. So moving to iterators. Iterators are objects that allow you to iterate over a sequence of elements, providing a sequence of values on demand. When you talk of iterators, what comes to your mind? Loop. When you talk of loop, what comes to your mind? For those that come from other programming languages, obviously, the for loop is an interesting loop that almost all languages have for looping, although different languages have it with different syntax on how they use it. Also, the while loop is another loop. In the case of Rust, it's literally have the syntax loop itself as another type of looping syntax to loop through a series of objects. But then, is there a way for us to actually loop through these vectors or objects, sequence of objects, without with performing more actions on it. Yes, and that's where iterators comes in. Iterators literally help you to do looping in that sense, and then it allows you then to basically have the power to perform more actions, series of actions. In fact, you can perform chain of actions as we would be seeing in this course today, in today's class, series of action on an ITER. And so iterators literally provide a consistent and efficient way to process collections, avoiding manual loop constructs. So without you having to create your for loop, to create your while loop, or for you to create your other type of loop, like loop itself, basically. So the iterator literally does this, and it allows you to create this sort of loop while performing actions on it. Creating iterators. Creating iterators is literally simple. All you have to do is, now, since we spoke of sequence, that iterators are used for sequence. Example of a sequence is literally the vector. The vector, in this case, vec of 1, 2, 3, is literally a sequence of 1, 2, 3. And so in this case, to convert it to an iterator, all you have to do is to call the method iter, and immediately the vec 1, 2, 3 literally implements the iterator trait, and it creates a custom iterator that allows for more complex iteration based on whatever logic that is needed. As I've made mention of, using ITER literally creates for the opportunity to use so many methods that is related to the ITER. And some of this method is the method that I discussed from yesterday class that I actually used. And the reason why I actually said, okay, yes, we use this, but it was not properly explained. We need a class on it, and that's why I embedded it in today's class. So yeah, the custom iterators with iterator traits. In this case, this is an example of what it looks like. So if you want to create like a custom iterator, now for the example we have here, we have a counter. The counter is a struct that has counts. So you can basically implement your count that starts from 0. And then when you implement that count, you can basically now implement an iterator trait on it. An iterator trait is literally a trait. And I know we have not spoken so much about traits, but I'm sure we've been hearing of it from different classes when I spoke of even the debug traits, spoke of the clone, the copy traits, when I was talking about struct. Yes, all of these are traits, but I have not gone deep into traits. We definitely have a class where we talk about traits, where we go deep into the trait itself. So implementing this trait, to implement a trait for a struct, this is how you do it, as you can see on the screen. Implement the name of the trait for the struct. So this type item equals U32 is just basically a way to change the type into whatever custom name you want. And so for now, for this case, we are trying to create a custom trait named a custom iterator trait named next. And so what does the next do? It basically counts and increase the count. This count that we have in the struct is basically increases it by 1. And then if the count is less than 6, it basically does what? It returns it. It says some self.count. So it returns it as an option of itself. If not, it returns else. So this is literally just an example to show that you can create an iterator with different things. You can create an idea of what you want to, iterate. And as long as you implement the iterator, your iter can use certain method that is used by the iterator added to your code. And in this case, next is actually a method that is associated with the iterator trait. And so we can remodify our own nest and do it the way we want it to be done. So you can basically make a custom iterator, and that's exactly what this example, as you can see on the screen, is talking about. Does anyone have any question? Any question? Okay, proceed then. Common iterator methods. Different iterator methods include nests, collects, map, filter, and we have so much more. We have so much more. That's why I said, okay. Okay, I can see you.
Can you please go back to the previous slide?
Okay.
Sorry for the type item so I didn't get that one. You missed it. Are you trying to implement a specific type for a trait? So I don't know how it works. Is it like it must be done this way, or you did it just this
Definitely
yourself?
not. Definitely not. Definitely not. You see,
Okay.
the keyword type is basically used to convert a data type, an actual data type, to whatever name you want to name it. In this case, we converted the U32 that we were using here into type item. So in this case, it could be a string. And here we don't want it to say return string. We want it to say return, because you could have a code whereby you want it to be quite readable. And so let's say you have a data type string, and instead you want the data type throughout your functions to be called coxy. You can basically use this type, equate it to coxy. So you just say type coxy is equal to string. And then wherever you are using string in your function, you can make use of coxy. That's just it. It's just used to change the type name. So just to make your code
Okay.
more readable.
So like on a normal day, this option stuff is made up of like string or so string like the return type.
Not
So
string.
like
I just made example of string. In this case, as you can see from this code example, it is a U32 type. Does that make
Mhm.
sense? It's a U32
Mm.
type. I just made use of your name just for you to know you can even equate your name to whatever data type you want to make it. So instead of, let me go back to my code and just make an example of this. Let me stop presenting and present my own screen so you can see an example of what I'm talking about. Let me look for, okay, let me just, okay. In this case, we have U32, right? I can come here
Yeah.
and say type, let me name it IO is equal to U32. Can you see? So wherever U32 is, I
Yeah.
can use I. There's no
Okay.
problem. So that's just basically,
Okay.
it's just used to rename a data type that you are using. You get. So
Okay. Yeah. I
sometimes people use it to, make their code more readable. And making your code more readable, it's basically helps you in future time as to, what a particular code is doing. Don't be surprised when you see this in so many smart contracts whereby the data type is hidden at the back of a strange name that is created. So let me return this to what it was. Okay. So coming back, let me just continue like this. So there are different types of iterator method. We have next. Next is basically an iterator method that returns the next value in a vector. If you use the iterator value on it, iterator method next on it. We have collect. Collect is basically used to, after you perform so many methods on a vector, an ITER vector, you can basically use collect to collect it back as an array or as a vector back. Then map is basically a method that is even familiar to some of us that are quite acquainted with JavaScript. So with map, you can basically loop through the vector and perform any action you want on the vector, and then it returns the full vector which responds to whatever action you performed on it. So for example, imagine you have a vector 1, 2, 3, 4, 5, 6. You can basically iterate through it. Instead of, you can use the other looping methods that I've made mention of. Either you use for loop, you use the loop itself, you use while loop. Map is another one you can use. So I'm not saying that you can't use all these other methods I've made mention of, but just to make your code readable and easier, all of these other iterator methods are iterator methods you might need to know. So for map, it returns the full array. For filter does something. It filters it based on the condition you have in the closure. So map basically does whatever action you want it to do, each of the elements in the vector. So we have other ones like position that I used, find. All of these are other iterator methods. And so Rust provides a rich set of iterator methods that allow you to process sequences efficiently and expressively. So you can have, one beautiful thing about it again is that you can basically chain all of these iterator methods. So imagine for this vector, 1, 2, 3, 4, 5, 6. You can first of all add the iter method, which is going to add the traits to it. Then next, you can add the map. You can, inside the map method, you can say, okay, you want to multiply all of the variables by 2. And so that method map, all it does is it multiplies all the variables by 2. Then you chain it to filter again using the dots filter. Then you now say, okay, all the variables that has been multiplied into 2. Okay. Okay, that was a powerful outrage. Yeah, it just came back. I've missed a lot today. Yeah, the call is being recorded, and you definitely get it from Nomad. So you basically can chain it, as I was talking about. You can chain the map to the filter, and then the example I was giving. Imagine you chain the map. You made mention that, okay, for the map, you want it to multiply all of what you have here by 2. And then what it returns again, you want to do like a modulus, for example. In this particular example, a modulus is done. And then you're like, okay, only the values that are modulus of 2 should be returned. And then you filter it out again. And then you finally use the dot collect. So I've literally done series of iterations, and at the end of the day, this makes it powerful. It makes you make easier implementations makes you create easier implementations with the different methods you have on it. So training iterator method, this is literally what I have explained, and I was coming here to explain it, and that's just it. For the example that I even made mention of earlier, I used map first, I used filter, and I used collect. So that is already self-explanatory. So the training iterator method allows for elegant and powerful data processing pipelines. Okay. Powerful data processing pipelines, making your code more declarative. Okay. More declarative and concise. So iterating with for loops, the basic syntax and the usage of for loops. So for for loop, I basically just added it just so the whole topic about iterating is complete, obviously, I have talked about for loops before, and yes, for the Rust programming language, this is how you use the for loop for whatever the number or the data you are trying to loop. You name it. In this case, we named it number in the iter itself. In this case, it's numbers. The numbers is the name of the variable for holding the vec 10, 20, and 30 all together. And then with this, we can basically loop it. So the for loop provides a straightforward way to iterate over collections. They abstract away the details of the iterator, making the code easier to read. And that is, in fact, self-explanatory. Combining while loops and iterators. The example in this case doesn't use the iter. Instead, it uses the into iter. The into iter is another iterator trait that is basically used for certain methods when you talk about the iterators. In this case, one of the methods you use when you talk about into iter is the next. So it creates a situation whereby the sequence 1, 2, 3, which as the vector is literally created into an iter, and this iter can keep pushing out the next number based on the syntax we are using here, the whilelet syntax. I think I've explained the whilelet syntax in some slides back. So using the whilelet with iterators allows for more fine-grained control over iteration. It's useful for scenarios where you need to handle iteration in a loop structure. And that's exactly what we can see here. We are trying to iterate over 1, 2, 3, and we are trying to move from, it starts from 3. So for this first one, it prints out the number 3. Then next, it prints out number 2. Then next, it prints out number 1. So in this case, number is literally what it returns. So if you notice, wherever we are using the sum, it is usually as a result of our value coming from an option enum. And notice that most times we use the if-let for this option enum, and I've explained why we actually do that. We also use the while-let for the option enum, and I've explained why we do that. And this is just the combination of the past knowledge that I've explained some minutes back. So using iterator in real-world scenarios, processing large data size. For example, this is a large data set of 1 to 1 million. You use the dot collect and you convert it into a vector. This is one beautiful way of creating a large data size. Instead of writing vector 1, 2, 3, 4, 5, 6 until 1 million, you can literally create a large data size using this. For this, you can now use, imagine this large data size 1 to 1 million that you have now created. You map through it, and then you sum everything up. This is a beautiful one. See how easy this code is. Imagine you created like a for loop for this. It might take in so much resources when you come to computing it. So it might take in much resources compared to using this iter and collecting it and summing it up as a single variable. Another example is transforming data. So in this case, we have a vector of strings. So we named it let string equals vec. We have Rust, we have is, then we have awesome. Then the length, to check the length, we said string.iter.map. Then we checked all the length of each of these strings. Obviously, all of these things we can see here are not strings, they are string slice. But this function, we used it to iterate over it, and then we checked the length for each of it, and then we collected the length of each of it into a vector. So that's exactly what it shows here. So we looked through this vector of string slice, and we collected the size, that's the length of each of these string slides, into a vector. Imagine having to do this same implementation using the for loop. You would obviously take it through a different route. So the iterator method literally helps us handle different data size efficiently without having to waste your computer resources. So obviously, reference that we can reference to as we go more when it comes to the iterator is the Rust book, also the Rust programming language by Steve Klamnik and Cairo Nichols. You see, why I made mention of this, I've always talked about it. As a developer, one of the most important things you want to do is understanding how to go through documentation. So you obviously cannot have everything off your head, but knowing when to, go and reference, okay, what iterator can I use in this case for this situation? Then you see the different use cases of different iterators, and that's a beautiful one as it makes your programming experience seamless and better. So this is where we come to the end of the class for today. I don't know if there are any questions that is coming up from the class now. Are there any questions? I'll stop sharing. Okay.
So from the class yesterday, the library, I implemented like a category using enums, and I was wondering if you could like take a look at it.
Sure. We definitely can take a look at it. So
Okay,
just
I'll
make
just
it,
drop a link to the GitHub gist.
okay, great. I'm happy you implemented it. Just to make this video not too long for those that will be watching it, I'll be stopping the recording now. So we just check out your work.